Okay, review questions video, or part 2, I should say. Okay, we'll pick it up at 14. In 2009, there were 33,722 traffic fatalities. That is like awful. And 9817 were alcohol related. Okay, what's the probability that a randomly selected traffic fatality was alcohol related? Well, that would be the 9817 divided by 33,722, right? And so 9817 divided by 33,722 is 29%. 29.1%. That's A. B. The probability that a randomly selected traffic fatality was not alcohol related. Oh, well, if this is alcohol related, not would be 1 minus, or 100 minus 29.1, right? Because that's the complement, which is 70.9%. And C, what's the probability that 2 selected fatalities were both alcohol related? So probability of alcohol and alcohol. Well, the probability that it's alcohol related is 29.1, so 0.291 times 0.291, right? That's the probability of alcohol times the probability of alcohol. 0.291 times 0.291 gives me 8.46, or 8.5%. All right, so there's my and rule where you just multiply them together. Okay, D. What's the probability that neither were alcohol? So probability of no and no alcohol would be probability of no times probability of no, which is 0.709 times 0.709, right up here. That would be 0.503, or 50.3%. E. Probability, if there were 2, what's probably at least 1 alcohol? Probability of at least 1 alcohol. Well, that's going to be, it could be probability of no and alcohol, or alcohol and no, or no and no, right? I'm sorry, at least 1 alcohol. Alcohol and alcohol, right? So I've got these 3 cases to consider. So I could do this one plus, or is plus this one, or that one. Or I could look at what's the complement of at least 1. That's 1 minus the probability. If this is rain, it'd be 1 minus the probability of not rain. So at least 1 alcohol, the complement is going to be no alcohol. No and no, right? And that one we just did in part D. Oops. 0.503, which is 0.497, which is 49.7. Oops. 9%. All right. Number 20. So the complement is a big deal to make sure you understand the idea between the 2 complements have to add up to 1. Okay, number 20. Good. Get some room between these pictures here. Okay. 20. You draw 3 cards without replacement. Standard 52 card deck. What's the probability that all 3 cards are aces? Well, there are 4 aces in a deck. of cards. So what's the probability that you draw an ace? And an ace. And an ace. Well, that's going to be the probability to draw an ace times the probability that I draw an ace given I drew an ace before times the probability to draw an ace given I drew two aces before. So probability that I draw an ace is 4 out of 52. The probability that I draw an ace the second time, knowing I drew an ace the first time, well, that means there's 3 left out of 51. And then the probability I draw another ace, well, how many aces are left now? 2 out of 50. So if we do that, we get this guy right here, 0.00018. So not likely to happen, which is 0.018%. 23. That was 20. 23. How many different vertical arrangements are there of 10 flags if 4 are white, 3 are blue, 2 are green, and 1 is red? So I've got 10 flags, right? Okay, so this one, sorry, I had to take a pause there. So this one has actually, I'm going to draw it a little bit differently. This is a challenging one. So try to see if you stay with me here. So we got 10 flags. I know they're vertical, but it's easier to draw them horizontal on my screen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 4 white flags. So I could put the white here, 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 and here maybe, right? Now, does the order, so the question is, how many different ways can I arrange the white flags out of these 10 positions? Right? I could do what I just did there. That's one way. I could do white, 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 right? There's all different ways I could do this. Now, does the order make a difference? Like if I switch these 2 white flags, is that the same arrangement? And the answer is yes, because they're both white. You can't tell a difference. So I have 10C4. That's the number of ways to arrange the white flags. And how many ways to arrange the blue flags? Well, same idea. 10C3. Number of ways to arrange the blue flags. 2 are green. 10C2 would be the number of ways to arrange the green. And how many ways to arrange the red? 10C1, which is actually 10. I got 10 different places to put those. Okay, so this goes back to if I've got so many different pairs of pants, so many different shirts, so many different hats, so many different shoes, how many ways can I put them all together? Well, you just multiply them together. So we're just going to multiply these all together. 10C4 times 10C3 times 10C2 times 10C1. And, excuse me, so I'm going to go 10, math, PRB, 4. That's 210 times, and then 10C3. I'm going to do second enter. It puts the same command, and now I can edit it. How's that for a shortcut? 120. So I'm going to do second enter. That's the blue entry. It puts my last entry in, and I can go back and edit it. 45. And 10C1 is 10. So then I just got to multiply those together. 210 times 120 times 45 times 10. It's a lot of different ways. Oops. What is that? 11,340,000. A little bit crazy there, huh? Okay. 26. And I said 30, but I actually have that on a different screen, so we'll skip that and come back to it. Okay. Yeah. All right. So 26 would be, because of mistaken packaging, we have a case of 12 bottles of red wine contains 5 Merlot, 7 Cabernet, each without labels. All the bottles look alike, have an equal probability of being chosen. 3 are randomly selected. So we're going to choose 3. What's the probability that all 3 are Merlot? Merlot, Merlot, Merlot. Well, there's 12 bottles and 5 are Merlot, so the probability they get the first one is a Merlot, 5 over 12, and times, what's probably the second one is Merlot? Well, I'm not putting them back in, so there'd be 4 Merlot left out of 11, and the third one is 3 Merlot left out of 10. So I'm going to go ahead and do 5 times 4 times 3, 60. Divided by 12 times 11 times 10, 13, 20. So the likelihood of this happening, 4.5%. So not very likely to happen. B. Probably exactly 2 are Merlot. Ooh. Merlot and Merlot and Cabernet. Or Merlot and Cabernet and Merlot, or Cabernet, Merlot, Merlot, right? Those are my 3 options, have exactly 2 Merlot. Okay, so the complement, I always want to think when I see something like this where I have to add a bunch together, I want to think the complement. The complement that exactly 2 are Merlot means 0 or 1 are Merlot, so that really doesn't make things any easier for me. So I'm going to go ahead and just calculate these separately. Merlot is 5 out of 12. Merlot is 4 out of 11. And Cabernet is 7 out of 10. Or Merlot, 5 out of 12. Cabernet, 7 out of 11. Merlot, 4 out of 10. Or Cabernet, 7 out of 12. Merlot 5 out of 11, Merlot 4 out of 10. Does that make sense? I'm just I'm picking them in order, and each time I take one out, the amount goes down. And if you do this, you get 31.8%. Okay. And the last one, probably no Merlot. That's Cabernet, 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 right? Which is 7 out of 12. Times 6 out of 11 times 5 out of 10, right? Because it goes down each time. Each time I pick one out, there's one fewer left, which is 15.9%. All right, and 32. Okay, coffee sales. Number of cases of coffee or filters sold by 4 sales reps in a recent sales competition. So here's the salespeople. Here's the different things that they're selling. Apparently, what's the probability that a randomly selected case was sold by Bryce? Well, a randomly selected case. These are cases. Okay, so total. Let's see. I'm sorry. Number of cases of coffee or filters. So this is coffee. Okay, so there's cases of each. Okay. Just want to make sure I'm answering the right question. So a randomly selected case was sold by Bryce. Well, Bryce sold 119. Bryce was randomly, whoops, I'm sorry, the probability that it was Bryce. That'd be 119 out of 1009 total. Okay. Which is 11.8%. Is this unusual? Yeah, over 10%. No, it's not unusual. I don't think it gets unusual till about 5%. B. Probability that was gourmet. Okay, so gourmet, there's 264 cases were gourmet out of 1009. So 264 divided by 1009 is 26%, 26.2%. C, probability that a randomly selected single cup was sold by Mallory. So this is where you have to be careful. We know it's a single cup. What's the probability it was sold by Mallory? Mallory given single cup. So given it's a single cup, there's only 625 single cups. So you have to read these carefully. And of those single cups, how many of them are Mallory? 75. 75 divided by 625 is 12%. D. What's the probability that randomly selected gourmet case was sold by Bryce? Probability of Bryce given gourmet. Because they're telling us it was gourmet. So of the gourmet, it was 264. That it was Bryce is 9. So 9 divided by 264, that's tiny, that's 3.4%. So is that unusual? I said, yeah, absolutely. Get my power cord here, and I just realized I haven't been putting I didn't set my microphone, so you've been hearing my pen mark on this. I do apologize for not catching that. So I guess I can pause and get set up. Okay, sorry. Oh my gosh, sorry I totally forgot to put my mic on, and so I know when I don't do that, you hear the tapping on the screen because the microphone's right on the screen. So sorry about that annoyingness. E. What can be concluded from the results of part A? Excuse me, A and D. Well, the probability is Bryce is 11.8. The probability is Bryce given its gourmet is 3.4. So since the probability of Bryce is not equal to the probability of Bryce given gourmet, we can say the salesperson and the number of cases are not independent, right? Because if they were independent, it wouldn't matter if we were talking about gourmet coffees or not. These would be the same. But knowing it's gourmet makes this 3.4%. But if it's just Bryce, it's 11.8%. So there's some relationship. So salesperson and type, what we conclude, are not independent. Okay, since they're not equal. Okay. F, are the events Mallory and filters independent? So usually we talk about the variables, not the individual people. Like here we're talking about these variables. So I'm going to say don't worry about these problems because I just want to worry about the variable of salespeople and the number of cases or types of coffee, I should say. Okay, that was 32, and then we do have one last problem that I want to hit since we're almost there anyway, so I apologize, this is longer. But let's look at number 30. During the 98 Major League Baseball season, McGwire of the St. Louis Cardinals hit 70 home runs. Of the 70 home runs, 34 went to left, 20 went to left center, 13 went to center, 3 went to right center, and 0 went to right field. So A, what's the probability that a randomly selected home run went to left field? Well, he hit 70, and the left field's we're 34. So 34 divided by 70 is 49%. B, probability that it went to right field was 0 out of 70, which is 0%. And C, was it impossible for him to hit a homer to right field? Well, was it impossible? No. Did he? No. Okay, so we've got to be careful. In an earlier problem, we said, oh, when the probability was 0, it was impossible to happen. That was getting an odd black roulette, which can't happen. But just because you get 0 doesn't mean it can't happen. It just means in these 70 home runs that we're looking at, it didn't happen. Okay, so no. All right, there we go for the last part of it. So, all right, good luck getting prepared for the test.